Hello everyone and welcome back to our channel. So today we will learn how to send Java Gradle app logs to Elastic Stack. So what we will do, we will create a simple Java application using Gradle and set up logging with logback. We will then configure the Elasticsearch, Kibana and FileBit to collect, store and visualize these logs. And this setup will help to easily track and analyze the application logs in real time. So first we will see the prerequisites. You should have an AWS account with Ubuntu 24.04 EC2 instance up and running. Then at least 2 CPU cores and 4 GB of RAM for smooth performance. And also you should have Java and Gradle installed in your system. So our first step is setting up Ubuntu EC2 instance. So first we will update the package list using sudo apt update command. Now our package list is updated. Next, we will install zip. We need it to install SDKman. So let's install it. Okay. So now it's installed. So next we will install SDKman. This SDKman allows us to install and manage different Java and Gradle versions easily. So that's why we are installing it. Now it's installed. After this, we will install Java using SDK install Java 17. So this will install the Java 17 in Java version. Okay, now it's installed. Next, we will also install Gradle with 8.13 version. So now our Gradle is also installed. We can also verify it. Let's verify Java first. I forgot to put Amazon 7 plus. Sorry, Java 17 is installed now. Let's also verify Gradle. As you can see, our Gradle is also installed with version 8.13. Now our next step is creating a Java Gradle application. So first we will create a directory named my Java app Gradle. Then let's navigate to that directory. Now we are inside the directory. So next, let's initialize the Gradle project. Sorry. So let's just copy and paste it here. So here, Gradle init creates the new project. Then type Java application here. This type Java application specifies a job Java application template. Then this DSL Groovy uses Groovy for build scripts and test framework JUnit Jupyter sets up JUnit 5 for testing. Let's run it. Okay, we need to enter the target Java version. So we have installed 17. So I use 17. Then we will keep the project name default. Then select application structure. So now our build is successful. Just type ls, let's list out. So here you can see our app is built along with its files, including Gradle, its properties, Gradle W. So first, let's navigate to the application directory. We have so here you can see your build.gradle file. So here you can see. Now what we will do next? We will remove the default build.gradle file. Then we will create our own build.gradle. So let's just copy this file and paste it here. So here you can see the plugins section. Here Java enables Java support in the Gradle project, and application defines the project as a Java application and allows specifying the main class for execution. Then there is repository. We are using here the Maven Central as a source for downloading dependencies. Then there are dependencies, SLF 4J API. This is a logging API that provides a common interface for different logging frameworks. Then there is also Logback Classic, which is a logging implementation that works with SLF4J and JUnit Jupyter. This is a testing framework for writing unit tests. Then there is application configuration. This specifies the main class entry point of the application, which is org.example.app. Then Java toolchain configuration written here. This specifies the ensure that Java 17 is used to compile and run the application. And there is jar packaging configuration. Here manifest specifies that the main class, which is org.example.app, should be included in the jar file. Then from this block here, This ensures that all runtime dependencies are packaged inside the jar. Then duplicate strategy equals duplicate strategy. Here you can see x dot exclude. This prevents issues when multiple dependencies contain duplicate files. So let's save the configuration. So next, we will create a app.java file. So let's remove this configuration first. Our configuration and paste it inside the file. So here, first are the import statements written here. As you can see here, there is HTTP server, then which is a lightweight HTTP server built into Java, and logger factory used for logging messages like info, warning, and errors, and also init inet socket address, which represents the network address with host name IP and port, and output stream here used to send responses to the client. Then this is our public class app. This creates a logger named app which log messages to the console and the file, which we will configure it in logback.xml data. Then there's main method written here. This the main method is the entry point of the application. So it throws the IO exception in case of network or input output. It will also write the message starting the application here. Then we are creating the HTTP server. And this creates the server at port 880 and here the 0. The second argument means the system decided how many connections to create. Then server create constraint context. Here defines the endpoint slash that handles the HTTP request. Then it extracts the client details, including IP, port, request URLs. Ignores the request from webvcom.ico and returns the 404 not found. Okay. Then it also logs the HTTP method get post example, the request URL and client's IP and port. Then it sends the hello from Gradle response with HTTP 200 OK status. Then there's lastly server start section. It starts the server at port 8080 and it will also return the message server started on port 8080 and application is waiting for and running the request. So let's save the application. Next, we will create a app test.java file. Let's also modify this file. So first are import statements. Here marks the method as a test case and ensures that the block of code runs without exception assertions. And then here's test class definition. The test class is app test, is designed to test the app class. Then we have written the test case. Yeah, this calls the main method of app using app main new string. Then it passes an empty argument array to mimic normal app setup and checks that no exceptions are thrown using assert does not throw this here. And if the main method throws an exception, the test will fail. And if it runs successfully, the test passes. Let's save this file. Now next, we will create a logback.xml file. Here, first is root configuration. You can see here. Then there's console appender. You can see the appender name is console. So what we will do, it defines an appender that logs to the console and it will write logs to the terminal. Then there is also pattern formatting, which we have formatted here. Then there is also file appender written here. It will write the logs to the specified file, which is app slash logs slash myapp.log file. Inside this app slash logs directory, you can change it to your own file if you want. And lastly, there is root logger configuration. It sets the minimum log level to info. This means only info, warning, and error logs will be recorded, not the debug logs. And appender console sends logs to the console, and this one sends logs to the file, which is myapp.log here. Let's save this configuration. Now our next step is build the application. So first we will exit the current directory and get back to the root directory of our project. Then let's run the Gradle w build command. This will build the project and create a jar file. So now our build is successful. Now our next step is setting up Elastic Stack for log monitoring. So let's Exit to directory first. Okay. So now our Java application is running and generating the logs. So let's set up the Elastic Stack to monitor these logs. So first, let's import the Elasticsearch GPG key. Okay. We'll add the Elasticsearch repository. Now let's update the package list. The repository is added to the system's package sources. After this, let's install the Elasticsearch. So just wait a minute until it's installed. Installing the latest version, which is 8.17.4. Okay, now it's installed. So what we will do next? Next, we will modify the Elasticsearch.yaml file. So first scroll down, inside the network section, uncomment the network host and write 0.0.0.0 next to it. So what we will do, what it will do, it will bind the all available IP addresses to. Then next we will uncomment the discovery sales host also, and we will keep it empty. Here we can specify the initial nodes for cluster formation. Then in the security, we will disable the expect security enable. We will set it to false from true. Now let's enable the Elasticsearch. After enabling it, we will start it. So just wait a moment until it starts completely. Okay, let's verify if it started or not. For that, we will check the status of Elasticsearch. So it's active and running. Now, what we will do, we will try to access it using the browser also. First, we will check, send the GET request to check if Elasticsearch is running and responding. So let's run this command. So as you can see, it has returned a JSON response. You can see the name and also cluster name, Elasticsearch, and also the version here 8.17.4. You can also see it on browser. Just copy the public IP address and paste it inside the URL. Colon and hold 9200, which is default port for Elasticsearch. Hit enter. So you can see the same response it has written to us. Now, next we will install Kibana. Pause the video, delete install. So now our Kibana is installed. Let's modify the kibana.yaml file. So here in the system Kibana server, uncomment the server port, then also server host uncomment it, and from localhost change this to 0.0.0.0, which will also find it to all IP addresses, all available IP addresses. Then scroll down and in system Elasticsearch, uncomment the Elasticsearch.host, which will connect it to Elasticsearch. Let's save the file. So next we will enable the Kibana. After enabling it, let's start it. We will verify if it's running or not by checking the status of Kibana. So as you can see, it's active and running. Now next we will install Firebase. Just wait a minute. FileBit is also installed. Now let's modify the FileBit.yaml file. So what we will do here, we will change the type to log from file string. Then we will also change the enabled to true, and we will give our own custom file path. So scroll down and change the type from file string. From file string, we will change it to log. Then let's comment out this ID part, my file string ID. Let's comment it, and then we will change it from false to true. Then we will give our own custom path to our my app.log file. Copy from it. So if you scroll down, just here, you can see in outputs, it is set to send output to Elasticsearch. But if you are using Logstash, you can just comment out the output Elasticsearch path written here, and then uncomment the Logstash output.logstash part here. So what will it will happen? It will send the data to Logstash, and then you need to configure the Logstash to send data to Elasticsearch. So let's save the file. Modification we have done. Now let's test the configuration using test config. So it's okay. Now next we will run the sudo FileBit setup command to apply the FileBit setup changes. So this may take some time. So I will pause the video. So now our index setup is finished. Next we will enable the FileBit. After enabling it, let's start the FileBit. Let's verify if it's running or not by checking its status. So it's active and running, as you can see here. Then after this, we will ensure that Elasticsearch is receiving data from by FileBit by checking its indices. So here you should see the FileBit index. So here you can see FileBit is present. Now our next step is run the application. So for that we will go to the root project directory first. So now we are inside the root project directory. Now let's run the jar file. Let's execute it. And run it from outside our project directory also. Let's run it again. For here the part full part here, including our project directory. So now it's running. As you can see, the application is started. The server is started on cold 8080, and it's running and waiting for incoming request. So let's open your browser, copy the public IP address, paste it inside the URL, then colon, and hold APLT to access the application. And here you will see the hello from Gradle message. Now, if you go back to the console, you can see the same message is generated here. Same response, hello from Gradle, and also receive get request from URL, which we have written in the URL box. Let me just run this process. Okay. And you can also see the files, see these logs inside the logs slash my dash app dot log file. Let's also try to verify Java Gradle. Sorry, let's first go inside the directory. Log now dash dot log. Let me go admin created outside and command out and logs my dot log. So you can see the log messages are stored inside our my app dot log file. Now let's start Kibana here. Copy the public IP address, paste it inside the URL, and this time we will use 56014, which is the default code for Kibana. Now here, go down and under the observability section, go to logs. So here you can see the log which is generated. Here you can see the same response, hello from Gradle, which is written here. You can see the hostname, also the cloud provider, which is AWS, cloud region, availability zone, and also other details like log path file, which you have written in filebit.yaml configuration. So now you have successfully set up the Java Gradle application that logs the incoming request and sends them to the Elastic Stack. And with Elasticsearch storing logs, Kibana visualizing them, just like we have did now, and Filebit handling the log forwarding. You will have a powerful logging solution. And this setup, which we have seen today, let me just correct this command here. So this setup helps you in real-time monitoring, debugging, and improving the application performance. And you can also further enhance this by adding the log stash for advanced log processing. So what it will do? It will filter the logs, complex logs, or you can integrate the alert for monitoring. So that's all for today, guys. Thank you.